a record of this for later on. So yeah, so obviously this is the second of the sessions. The first one is available on YouTube if you want to catch up on it if you haven't seen it already. Just gonna carry on going through 2.1 today, which is looking at algorithms. This part is looking specifically at the searching and sorting algorithms and how you can kind of teach them, or how I teach them anyway. Obviously, it's not the only way, but it's what I find useful and ways that tend to work with the students that I have. So when it comes down to it, the searching algorithms are the most straightforward, really. Um, Although they're not expected to know the code, I always find it useful to show the students the code and get them to understand it, because they are possibly going to be asked to explain what a particular algorithm is doing. And if they've seen it before, then they should be able to identify what type of algorithm it is. So the two searching algorithms that they need to know are the linear and the binary. The linear is a really straightforward one, really. Looking at just going through each item in the list in turn and comparing it to the value that you're looking for. Typically starting on the left, and I think all of the algorithms that the exam will use will start on the left and then just go one by one across the list or the array as it goes through. Some of the key bits with this one, obviously, it is really simple to set up. As you can see, you've got the example up there. You've really just got a for loop with an if statement. The print I tend to put in there just so they can see what's going on as it goes through. And then the returns is just because it's a function, and you can do it quite easily without doing the function as well. See, with this linear search, it doesn't matter if the list is in order or not, which obviously means it can potentially be a little bit more useful. It's get a little bit of a pain though if there's a long list of items, obviously because it has to go through and check all of them, and so that's kind of where the trade-off will come with it. But like I said, it's a very simple algorithm, and even your lower ability students should be able to code it, even though they're not expected to be able to. Obviously, the binary search is a little bit more complex. It's looking at how the list can be sorted a little bit more quickly, but it has to be in order to begin with. When it comes to setting up the algorithm, you've got these pointers that are needed so that you can then look through and check various parts of the list, and it's just checking the middle item in the list each time. And if there's a match between the middle item and the item you're looking for, obviously then it will return that it's been found. Otherwise, it's going to check to see if it's lower or higher, so it can remove part of the list each time. With the algorithm, it doesn't delete anything. It will just change the high and the low pointers to get rid of the part of the list that it now doesn't need to look in anymore. Obviously, this can reduce the number of searches that it takes, or the number of comparisons that it takes as it is looking through the list. But like I said, it is a more complex one to be able to code, and it has to have been sorted beforehand. One of the kind of the key bits for this one, and the biggest misconceptions that they have, or the students have with this, is when it talks about binary, they seem to think that it's ones and zeros, and it can only be ones and zeros for it to work. Obviously, it's not the case. We're looking at the fact that it's splitting the list into two, really. That's where the binary element comes from. And so it's really useful to make sure that you teach this with both number lists and string lists as well, just so they don't think, oh, it can only work with numbers and it can only work with strings. I think it was last year there was a question in the paper that was talking about why some data couldn't be sort of searched for using the binary search, and students got really confused with talking about the fact that because it wasn't in ones and zeros, or because it wasn't just numbers. I think there was some text in the list from memory, and they thought that it had to be numbers to be able to use the binary search. So it's obviously really important, I think, to make sure that they see it working with both numbers and text as they go through, and even combinations of the two, which I think is what it was last year. It was like a booking references with numbers and text in it. As I'm teaching these, I tend to do these in one lesson. It tends to be quite easy to go through. But what I'll get them to do is to show how it would search. I'd get them to explain the different steps it takes to go through. And then I'd kind of finish up with looking at the actual algorithm itself, get them to label the code. So, and kind of a mini prim lesson. So some of you may have seen the resource that I put on, because over the last week of how we teach the programming at our school using the prim method, and you can do a kind of mini prim with this one. You can give them this code and you can get them to explain what they think is happening, and especially with the binary, it's useful almost to get them to do it line by line what's going on. And then you can get them to change it in some way. So it might be that you decide to remove one of the sections and they have to add that section in there, so that maybe you don't give them the algorithm with the check to see if the midpoint item is bigger than the search item. And you expect them to be able to add that part in there to get it to work properly. Something on those lines can help to get them to understand what's going on properly, and hopefully when it comes to the exam, it will then give them kind of that more thorough understanding of how those algorithms do work. And obviously if they've got these prints in there, it can help them to see what's going on. So if with the binary search, I'll just get them to print the high, the low and the mid value, so they can see what the numbers are doing. So these are the indexes. So the index of the lowest item, the index of the highest item, and then the index of the middle item. So you can then use those within the if statement to check against your search item, just using some array indexing later on. So they're fairly straightforward in order to be able to understand, and to a certain extent to be able to code. I think the binary one, you probably get the higher ability would understand it a little bit more than the lower ability, but it is kind of an expectation that if they see the code that they can try and start to explain it. So every so often it's worth coming back to and giving them this algorithm, not necessarily saying it's the binary search. So I just call it algorithm as the function name, for example, and then I get them to explain what it's doing and what the point of it is. And if you keep revisiting that every so often, then that'll be quite useful to do, I think. The searching algorithms are a little bit different and a little bit more complex, and I'll go through each of those kind of separately as well. I tend to start at the bottom with the insertion sort, because it's slightly more easy to understand one, I suppose. So the idea of the insertion sort is that it will look at each of the items in turn, and it will put it into the right place into the sorted list. And so the way that this will be done on the computer with the algorithm is that you'd have one list, and you'd have a sorted part of the list and an unsorted part of the list. Typically the left hand side is the sorted part, and you look at each of the items in turn. The first item will obviously already be sorted as such, so in the first loop. So as it goes through, it will then go to the second item, and then it will look at that second item, and it will then go through and compare the second item to the first item and put those into the right place, and then you've got a sorted list of two. and then it goes through to the third item and does the same. What I tend to do is I have a presentation that I'll go through like this, that just goes through this step. So obviously I've got a list in there. So we start, and 4 is in our sorted list, so we can then go along to 2. Okay, so 2 gets inserted into the right place. Then we take 7, which is already in the right place, and so on, as we go through, obviously building up this sorted list. And I try and encourage the students, especially when they're answering exam questions, to highlight the sorted part of the list each time, and they should get this kind of step-like feature if they've managed to show it in the right way. It really kind of helps to show exactly what they've been doing, and when it comes to marking it, it makes it a lot easier for the examiner to be able to see what their train of thought was if they've highlighted the sections that they've been looking at. So those sorted parts and the unsorted parts, you can really clearly see if they highlight one of them or even both of them in different colours if they choose to do it like that. And so this is what I try and get the students to get in the habit of as they're showing it, which is one of the kind of main questions that they'll ask in the exam relating to the sorting algorithms. Show how this list would be sorted with the insertion sort, with the bubble sort, and so on. Just going to get back. So it's a fairly straightforward process in terms of writing the algorithm. You've got a nested loop, so the first loop is to go through each item in the main array, and then the second item is, or the second list loop, I should say, is to go through the sorted part of the list that we've got so far, and then work out where the swap needs to take place to. So where are we going to move our item to? And so it is very straightforward. It's just doing a quick comparison to see if the item that we've got is bigger than or smaller than the items that we're looking for and looping through in the list. Like with the search algorithms, they're not expected to be able to write them, but again, at the end of this lesson, so with the insertion sort and all the sorting algorithms, I'll go through and I'll do a lesson at least on each of them, because they do tend to take a little while longer to get their head around what they mean. And at the end of that lesson, there will be the code, and I'll get them to go through and change the code and trace through it and explain what they think's going on, so they can obviously explain that as they're going through. And then, like with the other algorithms, just revisit them, give them the algorithm every so often, and then get them to explain which of the sorting algorithms you think it is, or whatever it might be. Again, I think it's good to show them with both numbers and text. When it comes to text, especially some of the students, especially the lower ability, don't seem to understand that it can be sorted. You can have letters after in the alphabet, and obviously that's how it's sorted when it comes to it. So I think really going through and using it. A really quick visual tool for it that I'll tend to use is just packs of playing cards as well. So if you just want something when you're just quickly doing a revision activity, you can give them a set of cards and then get them to show how the insertion sort would work, or how each of the different insertion sorts work. So it's a nice, really quick revision activity that you can do with them, or even for those that are kind of a little bit slower to pick up how it actually works. You could just get some of them together and just say, right, let's go through this, and you can move the cards around on the desk in front of them and get them to see exactly how the comparisons are going through, as opposed to my quick demonstration that I do with the PowerPoint slide. The bubble sort is obviously a little bit different in terms of it tends to take a little bit longer to be able to search or to sort the list. Again, it's made up of two loops, so you've got a main loop that goes through and deals with the passes, and then we've got the inside loop which is going through it and doing any of the swaps for each of the passes. And so the way that the bubbles will work, again, I'll just go through this. I have a slide set up for this, and again I can go through and show it. Obviously it does take a little bit longer, so I haven't shown all of the passes with this one, but with this one I'll highlight the two that are being compared. So we look at the first two items, compare them, they're in the right place, so we don't do anything else. The second two we do the same, so we're now looking at item 2 and item 3, and again those ones don't need to change. The next one, the 7 and the 1 need to switch around. Okay, and then the 3 and the 7 will switch around, and then the 5 and the 7. And at this point we're at the end of the first pass, where we've got the highest item, so 7 is already at the end, but we haven't got a fully sorted list, so we have to go through and do another pass as we go through. So we then go back to the beginning and take the first two items. Those ones are okay still, but then the next two, they're not, so they would be swapped. I haven't gone any further than that because it does take a little while and I need a bigger slide to be able to do it, but hopefully you can start to get the picture with it, and the students normally do start to get the picture at that point. Again, the highlighting part is really useful for the exams, so when they go through and highlight the two items that are being compared and have been swapped, then it will be really useful. Some of the students tend to get a little bit lazy and think that they shouldn't do all of the steps, but it makes it a lot easier to see their thought process if they show every single comparison to show that they understand it. Typically, I think in an exam they'll have the list set up so that it doesn't need more than kind of 2, maybe 3 passes, so it shouldn't take too long to show. The ones I tend to give them in lessons do sometimes take a little bit longer, just because I just choose random numbers and try and choose the same ones for insertion and bubble sort, so they can start to compare. They don't really need to be able to compare the different searching algorithms or sorting algorithms at this stage, but I think it is useful to start to introduce that, especially for those thinking about going on to A level, where they will have to start to think about which one's better to use and why. So with the bubble sort, obviously because you've got those extra passes, it does take a little bit longer, or can take a little bit longer to go through and sort. One of the key parts of the algorithm side of things, though, is the flag that they've got. So there's this true flag to indicate when there has been some swaps or some changes, and that's kind of the key tell as to which of the sorting algorithms this is actually using. Obviously this is used to determine when the main loop will stop, so that it knows when we've done all of the passes that we need to, and it will do an extra pass after all of them have swapped. So as long as there's been some changes, the algorithm will keep going through, and then once it's been through the nested loop and there haven't been any changes at all, that's when the outer loop will then stop and the program will then finish. And so it is a little bit more complex in terms of coding and starting to understand, but again, I think giving the students the algorithm to start to look through and to label and trace through is really useful for them to be able to do it. And I think it was the bubble sort that was in the exam last year as well, where they did have to have a look at the algorithm and work out what was going on and what the key parts of it, and be able to explain things like the flags and the purpose of those. And lots of students did struggle with that. So I think I would definitely recommend going through showing the algorithms as much as you possibly can, and talking through them. Again, using a kind of prim style method at the end where they start by just predicting what they think it's going to be doing, labeling the lines of code, looking at editing it in some way so you could miss out parts. So maybe forget to change the flag to true when it's finished, and see what happens, and those sorts of things, just so they get used to investigating what the code is doing. And then the final one is the merge sort. This one I think is probably less likely to be shown in an exam because it's made up of typically two different functions. So there's a lot of code there, and I think it's quite obvious, and hopefully it should be quite obvious, that if there's a lot of code to it, the student should be able to realise that this must be the merge sort. So it's not as important to be able to go through, but I think it's still useful to show them the code of how it works. And so the merge sort is looking at splitting the items down into individual items. And so it splits the list in half, and then half again, and then half again, all the way until you've got the individual items. In, I think it was the first J276 paper, where it obviously went to the two components, I think they had the merge sort in, and the step that most students missed out was that individual components. And so it will split it down right into these individual elements of the list before starting to merge them back up. And again, I'd go through a little bit of a diagram with them so they can see the list. This is probably a slightly trickier list than they'll get in the exam. Typically, I think they tend to give them 8 items because it's a little bit easier to look at and understand the merging effect when you've got an even number of items on each side every time. But it isn't really any different in terms of how it works as it goes through. So we're splitting the items down into the different sections, so split in half again. And now at this point I've got my individual items, and now it can then start to merge them all back together again. So it takes 4 and 2, merges those into the right place. 7 is just going to stay on its own at the moment. 1 and 3 get merged together, and 5 will stay on its own at the moment. And then those halves can then be merged together as well. So we've got the 2, 4 and the 7, and then the 1, 3 and the 5. And then once we've got that part all sorted, we can then merge those 2 halves together, and obviously we then get one sorted list at the end of it. Found a quick way to do this. So the merging sort of is the most complex, but it is one that is obviously a lot quicker to do for longer lists. So as the number of items increases, the number of comparisons doesn't increase as quickly as the merge sort or the double sort as it goes through. So it is a really, really useful algorithm, but it is obviously a lot more complex, and it tends to use a lot more memory as it's going through as well. But again, like with the insertion and bubble sort, using cards to go through and to be able to create a quick revision activity is really useful. And I said, just revisiting the code and just showing it, so it could just be a really quick starter activity as you go through. So just gonna stop sharing this screen for a second. So this is kind of what one of my lessons would look like with the sorting algorithms. So this one was the bubble sort. So the PowerPoint up here had that same diagram, and then it was split down. So I got them to go through and show how it would be sorted. So I looked at them just explaining what the steps would be, but also getting them to show the steps, because they may have to do both. So the explanation would be looking at kind of more in words, explaining that the first two items would be compared, then the second two, whereas the show and the steps is more of here's the list after the first comparison, here's the list after the second, here's the list after the third, and so on. And so once it got through to that part, I then gave them the code at the end, so giving them a version that they then have to go through and explain, then give them the chance to run it and see what happens. And they can then have a look at seeing what happens with longer lists and more unsorted lists, looking at the number of changes and things like that. And then I got them to reflect back on the previous lesson that we've done, where we were looking at the insertion sort as well. So obviously, kind of there's lots of different parts to it. I think if I go through so this was the merge sort, so similar sort of thing, and I go through and I've used the same lists each time, just so they can see those comparisons as they go through, and I think that kind of is useful for them to be able to see, so they can see what's going on, and how the insertion sort and the merge sort and the bubble sort all work in slightly different ways. So again, I gave them the code, and then because this was kind of the final one, I got them to kind of explain how the different ones work and the comparisons with that in there as well. Like I said, it's not technically necessary for the exam if you look through what it's asking for them to do, but I think if they are able to compare them, it helps them to identify what the key aspects and the key things that they need to be able to identify when it comes to the exams. If they're looking for the algorithms, if they've had a look at really how it's working, then they can go through and hopefully identify those algorithms a lot easier in the exam. Obviously, you don't need to get them to program from scratch at all. You might, as a little bit of a extension task for some of your higher ability, get them to do it every so often, see if they can write the code for it at some point, but they don't need to be able to do that for the exam. So that's really it from me in terms of it. I don't know if anyone's got any questions or anything they'd like to add, any ideas that they use for teaching the algorithms or anything like that.
Hello, Martin. This is Neil Dickinson here.
Hello.
Yeah, hi. With regards to Key Stage 3,
Yes.
what sort of detail do you go in when it comes to this kind of sorting, searching algorithms?
Not a lot, really. Just looking at really kind of basic what they are, like the code side of things. I'd kind of show them, so we do some really basic looking at the code and get them to write the kind of copy and see what is working, but I don't really go into lots of detail with it. I think going forward we'll probably look to do a little bit more, because we're about to go to a 3-year Key Stage 3 from a 2-year Key Stage 3, so we're going to have to do a lot more of it, and so we'll probably start to look at doing these kinds of lessons where they're looking at comparing them a little bit more. But just kind of looking at the code, I think is at the moment is enough for Key Stage 3.
Yeah, well, just going through the steps, like with the playing cards and that. Would you say that's
just
sort of relevant?
just doing something like that is like how does it work? Look at them is something along those lines is quite easy. Something else, I think I've got a slide in that I forgot to do. So some of the other things, there's on YouTube, there's some videos by some Hungarian dancers. They're called the Algorithmics. So I'll just share the screen so you can see it. So yeah, so the Hungarian videos, that it's the Algorithmics channel on YouTube, and they're just some Hungarian kind of folk dancers that dance through and show how each of the algorithms work. And so I think I've got it open. I did. Which is a little bit of fun. The kids do tend to find it a little bit annoying at times after they've seen it a few times, but it definitely does help to get them to understand it. So hopefully you can see that. So you can just go through, and they've just got people with numbers on them, and they go through and they, yeah, I think they're about to start it. Go through and they show how this one's the bubble sort works. But they've got them for all the different algorithms as well. There are some sorting algorithms that don't need to know, like quick sort and heap sort, and I think they do those as well. But you can use those as videos. I think it's a little bit later on. So there we go. So this is a bit where they're actually showing. You've got in the background the different highlights of the indexes and so on, and goes through and kind of puts them under light and that sort of thing. And even just going through something like that with Key Stage 3 would be enough.
Yeah, yeah.
I'm just going to stop that because it does get a little bit annoying after a while. But yeah. Anything else from anyone?
Sorry, I don't mean to ask another question, but in terms of speed, right? So how do you explain how that one is faster than the other? Is that a case of that it does more things?
Yeah, so at this level, you're just really looking at the number of comparisons is what I would be talking about. So how many comparisons does it need to do to check and to get it into the right order? It wouldn't go any further than that. Once they get to A level, they start to look at something called big O notation, which goes into the maths behind how many comparisons there are and that sort of thing. But at GCSE, I wouldn't even start to touch that. It would be far beyond what most of them will ever need.
Yeah. Okay.
So anything else from anyone else?
I found that very useful. Thank you very much.
That's all right. It's not a problem.
I've literally got 3 pages of notes in my planner. I feel a bit better.
That's good. It's what the whole purpose of this is to be, is hopefully to be able to make things useful. As I said, I'll make the recording available so that you can look at it in the future if you need to and come back to it. But yeah, hopefully it's just obviously a little bit of extra bits that we can do. And if you've got any extra resources, does anyone else do it in a slightly different way at all?
I use the Craig and Dave.
Yeah.
And I have the PG online resources.
Okay.
So a combination of those two, and then whatever else I make myself, or that, but that's what I use.
Excellent. Do you find those useful as well?
Especially for somebody who started off quite clearly very non-specialist, the PG online stuff is very good because it covers everything in the spec and it goes through a list, so I don't miss out stuff, and I can make a PowerPoint home the day before and read it and be ready for my lesson. And Dave, their videos are really good, where I can just possibly sometimes even just set it for homework, just watch this video. Which is good for the kids, so they're not, it's easy for them to watch it and think about what we're going to do or what we did do in lesson, that kind of stuff. But I also use them in lesson as well, the Craig and Dave ones.
Excellent. No, sounds good. Brilliant. Has anyone got anything else to add? Any other ideas or anything? Any other questions at all? No. I'm happy to hang around for a little bit. If anyone does want to talk about anything else, I'll stop the recording now though, and I'll do another session next week where we'll look at doing a little bit of algorithms and that sort of thing, and looking at how we can start to teach those and get students to be able to write those in the exams as well. So I'll put the link onto the Facebook group later on, and we'll go through that next week. I'll probably go back to Monday next week because I think I've got some other meetings going on as well next week. But I said thank you for attending, and hopefully you did find it useful.
Yeah, thank you. That was yeah, again, awesome.